First function, it will be the constant function, and this function it is the 0 degree of the function, where f of x it will be b, where b belongs to r, any real numbers that we have. So if we draw f of x equal to any numbers of domain that is substituted in the constant function, it will be constant, it will be 2. So if we draw this function in coordinate plane, we find that every domain that we have, it will be 2. So it will be the straight line like this. So this straight line, it will be parallel to x-axis and intersect y-axis at 0, b, and b is a value in y-axis. So our value here, it will be 0, 2. Another function, it will be f of x equals 0. So every domain that we have, it will be equal 0. So our straight line, it will be coincident on the x-axis like this. Then this function, it will be intersect at point 0, 0. The last function, it will be in the negative value of y. So every domain that we substituted in this function, it will be constant. So it will be parallel to x-axis but in -3. So our intersect point here, it will be 0 and -3. Another function, it will be the linear function. This function of the first degree, and it will be the linear function that we represented by straight line. So if we have function like this, it will be 2x minus 3. So we make a table with a simplest point like this, 0 and 1 and 2, by substituting every x that we have, 0, 1 and 2, in this function to get our value in this table. So f of x, it will be -3 for the 0, f of x -1 for the 1, f of x equal 1 for the 2. Then represent it in the coordinate plane that we have. So by plotting this point 0, -3, 1, -2, 2, 1, to get this straight line. And x-axis intersect at 1.5 here, 0, and y-axis intersect at 0, -3. The second function, it will be 3 minus 2x. Then we plotting table like this with the simplest point 0, 1, 2. So by drawing this point 3, 1, -1, so we can get this straight line like this. So the intersect point for x-axis, it will be it will be 1.5, 0, and for y-axis, it will be 0, 3, like this. The quadratic function, this function, it will be of the second degree. So our function of the second degree like this, f of x equal x to the power 2 minus 3x plus 2. This is quadratic function of the second degree. We want to draw this function from x belong to 0 to 3. So our points that we want to substitute it in this function from 0 to 3. So we make a table like this, and we have 0, 1, 2. Substituting in the function, it will be getting it to 0, 0, 2. Then we make this point, then draw this parabola that we have in the quadratic equations. Then we have axis of symmetry, that we have the two parts like each other. So this is the axis of symmetry, and this is the vertex of the curve, that we have 3/2, 1.5, comma, negative quarter. So we want to have the equation of axis of symmetry. Equation of axis of symmetry belong to x-axis, so x equal 3/2, and the minimum value, it will be negative quarter. The minimum value that we have the curve decrease in this point like this, it will be negative 1/4. The another function, it will be negative x to the power 2 plus 2x. So we have the interval from -1 to 3, so we make this interval in the table by substituting this function, then plotting this point in the curve, and make another curve that we have, but here it will be the maximum value. So our vertex here, it will be 2, 1, 1. So the maximum value, it will be getting from y-axis like here, and the equation of axis of symmetry is belong to x, so x equal 1. So this example represents graphically each of the following linear function. F of x equal 5x plus 3. So this is the table of the simplest point 0, 1, -1. So by substituting this value in f of x, then draw this point in the coordinate planes that we have. This point for 0, 3, and this point for -1, 2. So this is the linear functions that we have. Another example for representing f of x equal -2. This is the function of constant. So we want to have the degree. The degree here it will be 0. So f of 5, it will be constant. Any number that substituting in x, it will be -2. So f of 5, it will be -2, and f of 2 plus f of -2, it will be also -2 plus -2, so it will be -4. Another graph for the function, and here it will be x minus 3 all to the power 2 for the interval from 0 to 4. Then find the point of the vertex of the curve, the equation of the line of symmetry, the minimum and maximum value of the function. So by making the function first squaring for x, it will be x to the power 2, and negative here, it will be 2 times 3, it will be 6. So times x, it will be -6, plus -3 all to the power 2, it will be +9. So this is the function for the interval from 0 to 6 by making this table and getting the f of x here by after substituting. Then draw this point like this, so making axis of symmetry. So our vertex point, it will be 3, 0. So the equation of axis of symmetry belong to x coordinates that we have. So x equal 3, and we getting the minimum or maximum values that we have in this function. So we find this function, it will be decreased. So this point, it will be the minimum value. So it will be the minimum value, it will be 0, belong to y-axis.